Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab. And in the search question number 191. So there is a question like a number of 1 bits, and it is also under the easy category. So click on it. Okay, so let's read the question. Write a function. So we need to write a function that takes the binary representation of an unsigned integer. So like we know the if there is an integer, how you are going to represent in a binary form. In a binary form is like 0 and 1. So a binary representation of an unsigned integer is been given. Return the number of 1 bit that it has. So as an example, so let's suppose like this integer is given. Basically, this is a binary number is given. So we need to count the number of ones. So if you count, so 1, 2, and 3, rest all are 0. So the output is 3. But how you are going to calculate this? Because this is an integer. Integer on integer, you can't like run a loop because this is an integer, right? So if you try to run a loop on the integer, then you can't run, right? Because if it is a string, then you can easily run. So one option is you can convert integer to string and then run a loop one by one, and then you can calculate. Okay, if character is 0, uh, if character like not equal to 0, then you are or if character is equal to 1, then you will increase the count is equal to count plus 1. That is the one way that you can do, but this is not the something like the examiner has been expected, because it is clearly mentioned it is the unsigned integer. So if the integer is given, just to solve your question, you can't convert into the string, right? So you need to find a way so that on the integer itself, how you are going to calculate the number of ones. So let's jump into the whiteboard. So we have like this integer is given, like, as an example, this one, which has 0 0 0 0 0 0 1 0 1 0. So output should be 2. Like, and how many like number of ones? This and this. And this one. So 1 minute. Yeah, and this one. So output should be 2. But how to calculate? So to calculate now, like there is a one approach which generally comes in the mind, because we can't run the loop. So if we can't run the loop, and because to find the number of ones, we need to iterate each digit, right? To iterate each digit, but this is an integer, so we can't run a loop. We know we can convert it to a string and then run a loop, but that is not what examiner is being expected, right? And this is not like which we should do, right? So what is the other approach? By treating it as an integer, and then how we are going to calculate. So the one solution is, we know like and or operator. So there is an and function, there is a or function, there is a XOR function. So there are so many functions, right? So we know if 1 and 1 is always true, and 0 and 1 is going to return false, right? 1 and 0 also going to return false, and 0 and 0 also going to return false. So there is only one condition when we are going to true, right? So what like how to calculate the number of ones? What if we just take the and of each digit? So this digit, then this digit, then this digit, then this digit, then this digit, and of that particular digit with the one, with the binary one. So as an example, if it is 0, and if we take the and with the 1, then I will get 0, because 0 and 1 is 0, right? I will get like false, or you can say 0. True is 1, false is 0. So I will not going to increase my counter. Then what I will do is I will take the and of this one and this one, right? So 1 and 1 is true. So if I get true, then I will going to increase my counter. Counter is equal to count plus 1. But the challenge is, for the last digit 0, I can easily like get the and. But how I can get the like and with this digit, right? So to do that, I need to shift this one first here, right? So I need to shift this one with one here, right? So as an example, so I need, so okay, in starting I can do the AND operation for this one, 0 and 1, and I will get 0. So count doesn't increase. Now I need to calculate the AND of this. But how we are going to calculate? Because to calculate, we need one at this place. So what I can do is I can shift this one at this place. So if I shift this one at this place, all the digit is going to be shifted. So this one, so this one second, this one come here, this zero come here, this one come here, this zero removed. So this is called as a right shift operator. So this is called as a right shift operator. So we need to shift it one by one. Right. So that's the only thing which we have to do is, and till what point we are going to write shift, because this is the binary representation and it depends upon the system whether you are representing in 32-bit or 64-bit or 128 bits. So till what point you are going to run loop, till we will get all zeros, until unless the number is not zero. So because if n is equal to zero, because if there is anyone here, if there is anyone here, then we need to shift until we will get all zero, right? So until zero means like the binary representation of zero is all zeros, binary representation of one is, so all zeros with one, right? So all zero with one. So this is the binary representation of the one. So we need to run a loop until we get the zeroth index. So what I have to do is, so we need to calculate the sum count. Okay, we have to calculate the sum count. Fine. So we need to increase this counter. But when we need to increase this counter, so what we have to do is, this is the n. This is our n. So what I will do is, I will take the and of n and 1. So this whole number, I will take the and of n and 1, and of n and 1. Right. So rest all will become 0. And for this case, I will like going to know like what digit at this place. All right. So I have to take the and of n and 1. So I will take if n and 1, n and 1, if this is going to return true, then I am to do count is equal to count plus 1. All right. Then I am to do the count is equal to count plus 1. All right. But if even if this is going to be true or this is not going to be true, so in first case I will do like the and. So this is false. Then what next? I have to do the right shift operator. So I have to do the right shift operator. So n is equal to, I have to shift the digits by 1. I have to shift the digits by 1. So I am shifting the right shift by 1. So now so now my n is this. Now my n is this, because I already I already checked this digit. Now I have to this. Now I am going to calculate again the and. So and with 1. So all zero and 1. So how to represent like in one in the binary, all zero and then 1. Then this position is going to be calculated. So now when I will do and, so 1 and 1 true. So if I get true, then I am going to do count is equal to count plus 1. But this loop needs to be done. This loop needs to be done. But till what time? When while n not equal to 0. So while n not equal to 0. So this loop needs to be run. And at the end, we are going to return count. That's it. So if you run it, so sample KC has been accepted. So let I to submit. So like our solution has been accepted and all the test KC has been passed. So like this is not like the easy question only, because if you want to convert into the string and then you just run a loop and then count the number of one, that you can do, but the examiner that definitely going to find, no, 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 you can't convert the binary into the string just for you are like finding the solution. That is definitely you can find the solution, but this is not like what the examiner is being want. So like we know this is the integer and we can't run the loop, then how we are going to do? Then this operators and operator come into our mind, because this is the only one condition when it's going to be returned true. Then what I can do is I will do the and with all the digits, because this is the binary. I can do the and with all the digits. So if I do with this digit, okay, I know, so this is the zero, I have false. So if I got false, I'm not going to increase my counter, but then I have to do with this digit. Then how I are going to do? So to do that I have to shift. So I have to perform the right shift operator, but how many digits I need to shift? I need to shift only by one, so I have to only shift by one. So and we need to run this loop. Until what point we need to run this loop? Until we shift all the ones, until we shift all the ones here. So it means until n is not equal to zero. All right, so that's it. That's the end of the video, and you can also try this question. Thank you.